Okay. Hello. Hello, everyone. Good evening, everyone. Good evening, Rishikesh. Good evening, Aishwarya. Good evening, everyone, whoever's watching this session. Actually, welcome to Letstute. Welcome to Letstute, each and everyone. So, first of all, let me just address if you're new to this channel, then do subscribe to our channel and don't forget to press the bell icon to never miss an update from us. Also, we have a lot of courses on science on our website, that is www.letstudent.com. So do check it out. The links, you'll find it in the description box and also in the comment section. Actually, in the comment section you can find the links. It will come in few minutes, so don't worry about the links. So we'll just wait for everyone to join this lecture. Okay. And today's topic, of course, let me just display it. um, we're going to do what is atomic number, what's atomic mass number, and what are isotopes and isobars. Okay, so let's wait for everyone to join quickly. Till then, we'll just revise whatever we have done in our past lectures. Actually, so in our past lectures, in our past live lectures, actually, we have been studying about what is the structure of atoms, what are the various subatomic particles of atom, like electron, proton, and neutrons, and how were electrons and protons discovered. We have seen the whole story actually, and that's an amazing story. And after that, how the race of finding the structure of atom begin, and how the structure of atom was proposed by so many scientists. We saw how it was proposed. So yeah, once again, just let me just address it, that whoever's new to this channel, then do subscribe to our channel and don't forget to press the bell icon. Yes, it's for 9th standard. Yeah, but this atomic structure topic is for everyone actually. Many of the grades have these topics, and these are important topics, like what is atomic number, atomic mass number, what is isotopes, isobars. Kids actually get confused between what are isotopes and isobars. So we will be clearing the doubt on that. Hello, hi Arun. Hello, good evening. So whoever's new to this channel, do subscribe to our channel. Hello, Akash. Do subscribe to our channel and don't forget to press the bell icon so that you never miss an update from us, and you be updated like all our live lectures. Okay. So yeah, and you can find the links for our website. Actually, we have a website in which you can find some amazing courses on math as well as science. Okay, so you can just check out the links in the description box, also in the comment section. Just check the comment section and you can just find the links. Okay, so let's quickly start actually. So what are atomic numbers? So we are first going to study what are atomic numbers. So what is atomic number? Till now we have studied that there are various subatomic particles in atom. Okay, there are electrons, there are protons. Similarly, there are protons. So what is the atomic number? Atomic number is nothing but number of protons in an atom. Suppose if I say in a particular atom there is only single proton, that means the atomic number of that particular element is 1. If I say that there are 11 protons in a particular atom, that simply means the atomic number of that particular element or atom is 11. So let me just write it down. Or okay, so if the number of protons, so this keyword is actually very important, that is number of protons. Okay, so the number of protons of an atom is known as atomic number. So it's known as atomic number, and it's very, very important. Now kids will ask that we have studied that the number of protons and number of electrons are actually equal in an atom. So if I consider an atom, suppose if this is an atom, the number of protons and the number of electrons are actually equal, because that's how an atom is neutral, right? We know that atom is neutral. So how an atom is neutral? Because there are equal number of electrons and protons in an atom. So why can't we take number of electrons? Why can't we take number of electrons to determine the atomic number? This should be a very important question, but try to understand this. While atoms combine together, while atoms try to combine together, they gain or lose electrons. So the number of electrons keeps on changing. What did I say? The number of electrons actually keeps on changing. So we cannot use the number of electrons. Therefore, we use the number of protons. Okay. So it's denoted by Z. So the notation for atomic number is actually Z. It's capital Z. So let's try to find an example. So in this condition, we have Z is equals to 1. That means the atomic number is equals to 1. Okay. So what will be the element? We know that there is an element called as hydrogen. It has only one proton. Okay, and that is the atomic number of hydrogen. So the element is hydrogen. So in this condition, if I have Z is equals to 6, that means atomic number is equals to 6. The element is actually oxygen. Okay, so this is how we find out what is the atomic number. If we know what is the number of protons, please try to understand this. If we know what is the number of protons, yes, very good, Vemi Reddy. If we know what is the number of protons in a particular atom, we will get to know what is the atomic number, because atomic number is nothing but number of protons. And I hope you got this thing, why we don't use number of electrons and why we use number of protons. Okay, so this can be asked as a give reason question, that why don't we use number of electrons to find out the atomic number, and why do we use number of protons? And because both the numbers are actually same, that is number of protons and number of electrons are actually same in an atom. Therefore it makes it neutral, right? Next is, what is the mass number? We have studied in the subatomic part about neutrons, nuclear atomic mass, actually, that the mass of an atom is actually the mass of proton plus mass of neutron. So these are the two things which we add together, and we get the number of protons plus neutrons gives us the mass number. Now, what is mass number? Mass number is nothing but atomic mass. Okay, so atomic mass is nothing but mass number. And what is the representation, or what is it denoted by? It is denoted by A, capital A. Okay, so the atomic number was represented by Z, and this is represented by capital A. So these are the two things which you are supposed to remember. Mass of an atom is nothing but mass of protons and neutrons. And why are we not taking electrons in this? I hope you remember the reason why we are not taking the. How do we get to know mass? Okay, I'll explain this. Okay, so protons plus neutrons. Why we are not adding electron? Can anyone tell me in the comment section? For mass of atoms, we are considering proton plus neutrons. Why aren't we considering electrons or mass of electrons? In the comment section, guys, I have explained you this. No, it's not because they are changing. It's because their mass is negligible. It's very, very small. It's very, very less actually compared to protons and neutrons. The mass of electron is negligible. Therefore, we are not adding mass of electron because it's very, very small. It's negligible. We can just neglect it. So therefore, we are adding the mass of proton plus mass of neutron. That will give us together the atomic mass or the mass number. Okay. So for first condition, let us take a condition of carbon actually. So for carbon, we know that the number of protons is 6 actually. But what is the mass of proton? The mass of proton is 6U, and the mass of neutrons is actually 6U. Okay, so we add both the values together, that is mass of proton plus mass of neutron will give us the atomic mass, and we know that the carbon's atomic mass is actually 12U. So this is the value. 12U is the value for carbon. Okay, so this was about carbon. Let's try to understand one more element aluminium. Okay, so the mass of proton of aluminium is 13. Okay, the mass of proton for aluminium is 13 and mass for a neutron of aluminium is 14. Now here there's a catch actually. Try to understand this. The mass of proton, and mass of the mass of neutron is actually different. So there are cases or number elements which has number of which have mass of proton and mass of neutron different. Okay, and there are cases where the mass of proton and neutron are actually same. So when there's mass of neutron, when there's mass of proton and neutron same, we just simply multiply it by 2 and we get the answer. So this is the answer for mass, atomic mass, and this is the atomic mass for aluminium. Okay, so this was about mass number, how to find out what's the mass number, or how to find out what is the atomic mass actually. So but kids can get confused in this thing, so my recommendation, actually a kind of trick, this is a kind of trick which you can follow. Please listen to this very very carefully. Okay, we know that the mass, the atomic number or the number of protons in carbon is 6. Okay, so this is the atomic number. This is the atomic number. So if we multiply this by 2, we will directly get the answer for its atomic mass. So this is a kind of trick which you can follow, but there are elements with which you can go wrong actually. In this condition, the atomic number of aluminium is 13. Okay, so this is the atomic number of aluminium, but if we try to multiply it by 2, we will get 26, which isn't the case in this aluminium. Remember, you can follow this formula. In certain elements, this formula is actually valid. So if you try to if you try to understand certain atoms or elements, you'll get to know that their mass is actually double their number of protons. So for example, if I have a periodic table over here, I don't know if you can see all the elements properly or not, but there are elements which have their atomic mass double of their atomic number. For condition, for example, let's take helium as an example. Okay, so the atomic number, okay, the atomic number of helium is actually 2, but the atomic mass of helium is 4. So what's happening? We are just multiplying it by 2 and we get the atomic mass value. For lithium, if you consider lithium has atomic number as 3, but the mass is actually somewhere around 6.7. Okay, so we can consider it as 6 also. So 3 2s are 6. Okay, so this can be a condition which we can follow. If you try to understand the boron thing, if you try to understand boron, the atomic number, so we can't see. Aishwarya, what I'll refer to you is if the numbers aren't visible properly. Try to understand this. If the numbers aren't visible properly, you can just do one thing. You can just write it in your notebook actually for now. But afterwards, you can just check a periodic table which will be there in your textbooks, or maybe on internet you'll find some periodic table. Just go through the periodic table and you'll understand whatever I'm explaining. Okay, so in this thing I was explaining, the atomic number of boron is 5, but the atomic mass of boron is actually 10. So there's a pattern over here that we simply multiply it by 2 and we get our answer. But try to understand this, it's not the case for every element. It's not the case for every element. If you try to do the same thing, you can go wrong. Okay, so for example, we just saw the aluminium one. Okay, so uh, atomic number of aluminium is 13, but atomic mass of aluminium is actually 27. So here you can go actually wrong. Okay, so you will have to be careful about which elements you can multiply it by 2 and which elements you can't. Okay, so this was the thing. Next thing is how to write. Actually, there's a general formula. Okay, there's a general formula to write each and every element. Okay, so in this condition, this H is nothing but hydrogen. In this case, I have taken hydrogen for an example. Okay, so hydrogen is the element name. So this is the name of the element. We write atomic mass number. The mass number we write it up. This is the mass number, and this is the atomic number. So this is the pattern we follow while writing the general denotation, or while denoting a particular element. So if for a particular element, for suppose hydrogen, if the atomic mass is given as 1 and atomic number is given as 1, we are supposed to write it in this manner. So H1 1. So this is the way in which we are supposed to denote. Yeah, so this is the way in which we are supposed to denote particular elements, or if they have given us the atomic mass or atomic number. I hope this thing is clear, guys. Okay, you can just type it in the chat box if till now it's clear. Okay, and then we can just move ahead, or if you have any doubt, you can just ask it in the chat box. But before going ahead, I'll just tell that whoever's new to this channel, please do subscribe to our channel and press the bell icon actually, so that you never miss an update from us. Also, we have a lot of courses on science on our website, that is www.letstute.com. So you can just check out videos over there. Okay, and the links are in the description box, or you can just find it in the chat box also. Okay, so let's move ahead. Okay, let's move ahead. So this is a question actually in which it's given if number of electrons in an atom is 8. Okay, so read the question very carefully. This is actually a textual question. Okay, so the atomic number, the number of electrons in an atom is 8. The number of protons is 8. Okay, so they have given us the number of electrons and number of protons. What is the atomic number of the atom? Okay, we know what is the number of atomic number of atom. We know that the number of protons is nothing but atomic number of the particular atom. Okay, so the atomic number, or how do we denote atomic number? Atomic number is denoted by Z. Okay, so the atomic number of this particular atom is actually 8. What is the charge? They have given what is the charge of the atom. Now remember, if number of electrons and number of protons are actually same, if number of electrons and number of protons are actually same, the charge is neutral. Okay, what is the charge on the atom? The charge is neutral. I hope this question is very clear to you guys. So video is not clear. Vemiredi, I think you should check your internet connectivity. Just check it. I feel it's clear from my side. Okay, so we just solved one question in which a question was given that a number of electrons were given, number of protons were given, and we were supposed to find what the atomic number. So atomic number of an atom is nothing but number of protons, and what is the charge on the atom? The charge on the atom is nothing but neutral. Okay, there's no charge, it's neutral because it's neutralizing. The electrons and protons are actually neutralizing each other. Okay, let's move to what are isotopes. This is, please say the question once again. Okay, I'll just explain the question once again. Don't worry, Aishwarya, I'll just explain the question once again. Okay, so if number of electrons in an atom is 8, They have given us the number of electrons. So number of electrons is given as 8. Number of protons. So number of protons is given as 8. Okay. These are the two things which they have given us. What they have asked us, they have asked that what is the atomic number. Okay. So the atomic number is nothing but Z, and Z is nothing but number of protons. So the number of protons is the atomic number of the particular element, okay, or the particular atom. And the next question, the second question is, what is the charge on the atom? The charge on the atom is neutral. I hope this you are getting the question very well. Aishwarya, I hope your doubt is cleared. Yes, Vemiradi. The answer is 8. Very good. The atomic number is 8. Very good, Vemiradi. Let's move to what are isotopes. Okay, so this is actually very, very important. But before understanding this, let's try to break this word actually. So this word is actually derived from a Greek word. Okay, this isotope word and isobars, these are the two words which are actually derived from Greek words. So let us try to understand what this isotope means. So we can divide this word into two, that is isos. We can divide this words into isos and topes. Iso means nothing but equal. Okay, iso means equal, and topes means place or place value. Okay, so place value you can consider for topes. Okay, so place, I'll just write place over here. Okay, so place. So atomic number, so that they have same atomic number but different atomic mass number. So understand this thing, why they have chosen this word as isotopes, that is equal places. So atomic number means they have same atomic number, or maybe they have same number of protons. Their place in the periodic table is actually same, so therefore they are known as isotopes. And there's actually a history behind this whole periodic table. There's a whole history behind making this periodic table. This periodic table which you're looking at is modern periodic table. And every isotope, or maybe the elements having same number of protons, are given a same position in this periodic table. We will understand that question at a later stage actually, but let's try to understand what are isotopes. So isotopes means same place, they are given same place, and same atomic number but different atomic mass number. Now, what does this mean? What does this line means? This simply means if I have a hydrogen atom, okay, in hydrogen atom we know that this is the atomic mass, this is the atomic mass, and this is the atomic number. Atomic number is denoted by Z, atomic mass is denoted by A. Okay, so this is the atomic number and this is the atomic mass number for hydrogen. Okay, let's try to look at one more element actually. This is also isotope of hydrogen, but now what you can see, the mass, the atomic mass is actually changing. The number of protons, please try to understand this. This is the number of protons. Okay, this is the number of protons. So this is actually same, but what is changing? The atomic mass is changing. Yes, I'm giving examples. So atomic mass, that is mass is changing. Now let's try to understand with one more isotope of hydrogen. So the mass is changing. It's 3. So this is the atomic mass, but the number of protons or the atomic number is actually same. So what are isotopes? Isotopes are nothing but same atomic number but different atomic mass number. You can actually make it rhyme. Same atomic number, different atomic mass number. What are isotopes? Isotopes are same atomic number, different atomic mass number. Actually these isotopes have different names also. Okay, so protium, deuterium, and tritium, these are the 3 different names for these particular isotopes of hydrogen. So this has atomic mass is 1, this has atomic mass is 2, and this has atomic mass is 3. Let's try to understand few more examples of isotopes. What are isotopes, or what are different types of isotopes actually? So we have, for example, carbon over here. So this is the atomic number. So Z represents atomic number and mass represents A. atomic mass number. Okay, so this is the atomic mass number of carbon, and this is the atomic number. Okay. Now one more isotope of carbon is actually 6 and 14. So this is the mass number. So you can see the change. It has changed. It was 12. It is 14 now. So these are two different elements actually. They have same atomic number but different atomic mass number, and both are called carbons. Okay, carbon 12, carbon 14, you have heard about this. This is carbon 12, carbon 14. You must have heard these terms actually. Carbon 12 is used for carbon dating actually. So these are different isotopes of carbon. Okay, now let's get to chlorine. Chlorine has 17 atomic number and atomic mass is 35. But of course, chlorine has one more atomic isotope actually. The next isotope of chlorine is with atomic mass 37. Okay, confused. Don't worry, when we're ready, you don't have to by heart these things. You don't have to by heart the examples. You just have to understand the concept. The concept is, what is isotope? Isotopes are nothing but same atomic number, different atomic mass number. So in this example, in this chlorine example, you can see they have same atomic number, that is 17. 17 is the same atomic number, but they have different atomic mass number. So these are different atomic mass number. I hope you got to know what are isotopes when we ready. Okay, I hope your doubt is cleared when we ready. So this was about chlorine, different isotopes of chlorine. Now a question must be in your mind that what should be the atomic number, atomic mass of particular chlorine? If we have two chlorines, for suppose, if we have two chlorine, this is the first isotope, this is the second isotope of chlorine. Now what is the atomic mass, or what can we take in general for the chlorine? So different, actually the chemical property of isotopes are similar. The chemical property of isotopes are similar. For example, in this condition, chlorine 35 and chlorine 37. Okay, these are the isotopes which have same chemical property. Their chemical property is similar, but their physical property is different. So one can have solid and the other can have liquid property, physical property. Okay, so these are certain properties of isotopes which should be followed. But in this condition about the chlorine, we just saw we have two isotopes. Please try to read these things properly. We know that there are two forms of isotopes for chlorine. One was of mass 35 and one was of mass 37. Both occur in the ratio of 3:1. Okay, so what is this ratio about? This ratio is nothing but what is the frequency of their occurrence in nature. So if you try to compare 35U, that is chlorine 35 and chlorine 37, there is a ratio between them. There is a ratio of 3:1. So if I have a whole part and if I divide it into 4 parts, so one part will be of carbon chlorine 37, and the other three parts will be of chlorine 35. I hope this thing you got clear. And this is not an atom. Please try to understand, this is your environment. So we are just considering this environment. In environment or in nature, there are 75% there is chlorine 35 found, and 25% there is chlorine 37 found. Okay, so this was about, but how to calculate, or what should be the atomic mass of chlorine atom? If we have two numbers, try to understand this. If we have two atomic mass number, which number should we consider? Which number should we consider? So in chemistry, actually they have defined it properly, that the mass of an atomic number is of any natural element is taken as the average mass. Okay, so we are supposed to take average. So for this condition, there are two elements or two isotopes. So we will take average of these two isotopes. So we are going to take average of these two isotopes. So let us try to understand this thing. So this is chlorine 35 and this is chlorine 37. What we have done, we are just taking the average of these two elements. So how are we going to take the average? So first of all, we just multiply 35 by 75%. Now, why are we multiplying it by 75%? Because we discussed that 75% is of chlorine 35. So chlorine 35 is present for 75% and chlorine 37 is present for 25%. Therefore, we are multiplying it by both the numbers. Okay. After solving these things, after solving this whole equation, you will get a value. You will get a value of 35.5 U. Okay. This Okay, Aishwarya, you're not understanding. You can just type your question or what you're not understanding in the chat box so that I can explain you much properly actually. Okay, so you can actually write it in the chat box. So this was about isotopes, but in this condition, 35 is not the original value. Okay, so this doesn't mean that chlorine has fractional atomic mass. This nowhere means chlorine has fractional atomic mass. It's just for simple calculation purposes that we are just taking the average. Okay. So this is an extra information given to you. You don't have to take it actually. You just have to understand what is isotope. So this is the definition which you are supposed to remember. Same atomic number, different atomic mass number. This is the only thing which you are supposed to remember for isotopes. Examples also, that's for simplicity or to make you understand what and how the what are the difference between different isotopes, how are the mass different. So but this is the only definition which you should know for isotopes: same atomic number, different atomic mass number. After that, let's jump to what are isobars. But before that, let's try to look at some applications of these isotopes. So there is an isotope of uranium which is used for fuel. So for nuclear reactors, it is used as fuel. Okay, and for cobalt, isotope of cobalt, you can see that it's used for treatment of cancer. So this is an isotope cobalt which is used for treatment of cancer, and there's an also isotope of iodine which is used for treatment of goiter. Okay, so these are the three isotopes which are used for various purposes. Let's jump to isobars actually. So what are isobars? We have studied for isotopes, the thing is same atomic number, different atomic mass number. But for isobars, it's completely different, or it's inverse, you can just see. It has same atomic mass. So the atomic mass is actually same. So you can just find it over here. They have same mass number, but different atomic number. So you can consider isobars as inverse of isotopes. In isotopes, we studied that it has same atomic number, different atomic mass number. But in isobars, we consider different atomic number and same atomic mass number. So this is about isobars. We have one example over here, that the atomic number of calcium. So this is the atomic number of calcium. This is the atomic number of argon. Okay, they have different atomic number. The number of protons, which we say, the number of protons or the atomic number for these two elements is actually different, but they have same atomic mass, and the atomic mass is 40. You can see it over here. The atomic mass of these two elements are 40. Therefore, they are isobars. And this word is actually derived from a Greek word, isos and bars, where isos means equal and bars means weight. Okay, so equal weight. So in this, it's considered as atomic mass. I hope this thing is clear to you guys. So yeah, that's it for this session. I hope this whole thing is actually clear to you. Let me just go through the whole thing actually. Let me just go back into the slides and explain you real quickly that the atomic number. So what is atomic number? Atomic number is nothing but number of protons. So this is the first thing which we learned. The next thing is atomic mass. What is atomic mass? Atomic mass is nothing but number mass of proton plus mass of neutron. So this was the thing which we were supposed to study in this thing. How can we write a particular element in a general form? So this is the general form in which you are supposed to write the element. So you're supposed to write the mass number over here. Here you will write the mass number and down you will write the atomic number. And this is the symbol. This is the symbol for the particular element. Okay. This is the whole periodic table. We just solved one example. What are isotopes? Isotopes are nothing but same atomic number, different atomic mass number. And what are isobars? Isobars are nothing but different atomic number, same atomic mass number. So guys, that's it for this session actually. But before concluding this session, let me just say that it was great teaching to you guys. And whoever's new to this channel, please do subscribe to our channel. And also don't forget to press the bell icon so that you never miss an update from us. Also, we have a lot of courses on science and math on our website. That is www.letstute.com. So do check them out. Okay. So I hope you are having a great day. Okay, guys. So if you have any doubt, you can just type it in the chat box. Thank you. Yeah. Thank you so much, Aishwarya, for being with us actually. Thank you, Vemi Reddy. Actually, even you were there with us. Okay, guys. So I'll just end this session. But please do subscribe to our channel, okay? And just press the bell icon so that you never miss an update from us. Okay? See you guys. Bye. Have a nice day. Bye.